Hello, it's Dr. Liu. Today we're going to talk about the second step on development of a robot simulator supporting OPC UA using Python, VTK, and WX Python. And this step is to prepare OPC UA robot information model in XML. OPC UA standard has already defined the OPC UA core models that can be applied in many places. Any domain-specific information model or companion specification can be extended on top of that. Among those, the robot companion specification has been carried out by a working group between VDMA and the OPC UA Foundation. So we can check out this OPC UA Foundation website to locate the online reference of this standard. So go to the reference.opcfoundation.org website. We can find the online version of OPC specification and the information model. So here is the list of the published information model. The first section is the core model, like address space model, service information model, mapping, those base OPC standard. So far looks like the device information model has become part of the core also, as well as information model. So on top of this base, there's called a companion specification, which is domain specific. So robot OPC information model is one of that. It's here. So the robot OPC information model was worked out by VDMA and the OPC UA Foundation. They released the first version in 2018. So this specification is called OPC 40010-1. So we click it, and here shows the overview and also object type, reference type, data type, event type definition of the OPC robot information model. So by click here, you can see here is information model overview. So on top of the base OPC UA and OPC UA for device, that is OPC UA for robotics. And the key object type is called motion device system type, which has a optional property called a component name, and the 3 component motion device, controller, safety states. Each has a component and which refer to a data object type. For example, the controller identifier, which refer to the controller type object type. So the controller type has optional component name, property, mandatory manufacturer and model property, as well as parameter set, software, task control, those mandatory object which has further component underneath. So start from here. If you go in further, you can find out all the detailed explanation of those object type, components, variable, event, and even all the reference and so on in this document. In this study, we defined a simplified robot OPC UA information model. We used a software called UA Model Accelerator, UMX, which is from a company called Beyond, which you can download from their website. So we use this software to define a new robot type under the object type, and instantiate this robot type as an object called a robot F16i, and then combine this information model as XML. So this XML file, further we simplified this XML file just to make it compatible with free OPCU package and easy to be imported into the developed robot simulator. So it's how this robot information model XML looks like. So here we are going to show how to use UMX software to create the robot OPCU information model. We can download this software from Beyond website, install the trial version, and when this software starts, it shows all the first it shows OPC UA standard information model namespace, all the nodes. Under the object type, we can add a new object type called the robot type, and under robot type we can add a few components, including two methods. So the components can be new object, variable, or property. For simplicity purpose, in this case, we define all the components as property. For example, the property program in cycle, program file name, speed of the robot, 6 joint position, as well as robot working mode, and as well as their data type. So for example, the program file name, can just click here, say add, you can add a new property. The program file name, the data type will be standard OPC UA base data type called string type. We can select it from here. So the two methods, one is update joint minimal and maximum limit. Another one is called a joint rotate, which has two input property, joint and angle, which specify which joint and rotate for how many degrees. So after we define this robot type, we can instantiate a robot type object, which in this case we call robot underscore F16i, and it will have all the components that defined in the robot type, robot object type. So we can create more object using the robot type definition. In this case, we only create one. So after that, we can compile and generate the robot information model as XML. Meanwhile, actually, it will also generate the C# class definition for all the object, which we're not going to use it. And after that, we see the created robot information model. Basically, all the defined nodes, it will be in this node set2.xml. If you open this one, we can see it defines all the nodes, this robot information model nodes. The first one will be the type with all its reference, which is the components, the property we defined, and then second one is the object, the robot F16i, with reference to all the components underneath this robot object. Program in cycle, program file name, speed, joins, as well as the method. So just to simplify the program and also to be compatible with the free OPC UA, we simplified this file and by cut off the type definition and only left the object object related nodes. So this will be the final robot information model XML file, which we're going to explain how we load this one into the robot simulator. Finally, if we start the robot simulator as an OPC UA server, by clicking this button, it will load the pre-created robot information model in XML and disclose its namespace through this endpoint. All the code are done in the class robot OPC UA server. We can take a look later. And then when the OPC UA server is running, if we open another OPC UA client, from that client, by linking to the server, we can browse all the server's OPC UA object address space, and we can see the robot's property like position, joint position, speed, working mode, and also can call its method. Now let's take a look of the code where we load this robot information model. We have two classes in the robot simulator Python program. First one is OPC UA server thread, which will be triggered when the start OPC UA server button on the HMI is pushed. Then, as you can see, we will create the robot OPC UA server object by set the endpoint, give its name, and also input this robot information model XML file. It's a string. And then when this robot OPC UI server object is created, the OPC UI server will start, and it will import this XML file by browsing all the nodes in the XML file and populate the OPC UI server namespace. Now if we start the robot simulator, and then we start it as OPC UI server with XML model by click this button, it will disclose OPC UI server at this endpoint. Okay, so here is showing OPC UI server on, and if we connect a OPC UI client to this server, especially if we start the robot running, let's see, we cycle start robot, run this cycle program, and now if we open OPC UI client, and in this case the UI expert, by connecting this to this OPC UI server endpoint. If we connect, we will see we can browse the object that in this OPC UI server information model namespace. All the joint, mode, speed, and the program file name, programming cycle, and also we disclosed two methods as well. So now if we drag and drop the joint, so you can see that the robot joint position still here. Will change, synchronize with the robot movement. If we cycle stop here, stop movement. If we go to the manual mode, we manually drag the robot. You see all this value will be changed. So if the client can access all the server exposed object. This is the end of this tutorial video. Please check out above YouTube video link to see the full video of the robot simulator.